Hello, my name is Tiffany. I'm one of your LAs this quarter. So if you're in my Tuesday or Thursday discussions when we went over examples for nomenclature, there were some mistakes. I wanted to go ahead and kind of make this video not only for the students that weren't able to make it to discussion this week, but also for the students that just want maybe to get a little bit more explanation for the examples that we did because we didn't really have much time. And I also wanted to, of course, correct those mistakes I made when I did the naming. So, of course, this video is not required. I just wanted to do this just to kind of fix those mistakes that I made. So I put up my email in case you have any more questions. Feel free to reach out to me. It's tchu12@uci.edu. So, of course, this week we talked about alkanes, and specifically we focused on nomenclature. So a little bit of introduction about alkanes. It's the most simplest hydrocarbons with a CC or CH sigma bond. So, of course, that's a single bond. Because alkanes don't have it's not a functional group, so there's not really too much to learn in terms of their reactivity. So we spent most of this section just focusing on nomenclature of the alkanes. We can go ahead and split alkanes into two different categories, which is acyclic or cyclic, basically if it's in a ring or not in a ring. So if we're dealing with acyclic, we have a molecular formula of CnH2n plus 2. And this is going to be linear or branched. So this molecular formula, we don't have to memorize this. We can kind of just see it, or whenever we see the name of the molecule, we can already know if it's acyclic or cyclic. But it's just kind of, I guess, neat an equation that the textbook had. So I wanted to go ahead and provide that. If we're dealing with cyclic or cycloalkanes, these are alkanes joined together in a form of a ring. And again, the molecular formula then, that's going to be CnH2n. So in a form of ring. Okay. So I guess we can call this our board. I went ahead to put some prefixes, suffixes, and all that good stuff. This is all in your textbook, and I only put a few. For example, for this, I stopped at 5. I didn't want to continue writing it. None of my examples I had went over 5. And then for my prefixes for the number of carbons, I went ahead to stop at 10, but there's definitely way more. But again, my examples don't go over 10 carbons, so I didn't see a point of adding those. Again, so you can find this all in your textbook. You can maybe even take a screenshot of that and kind of memorize it. It's not too hard once you start applying this knowledge to more practice problems. Once you do more and more, this will kind of just stick to you and you won't even need any of this at all. Okay, so let's kind of move forward here. So the simplest hydrocarbon, as we know, is methane. And I know this was brought up way, way early in organic chemistry or even general chemistry. There's the formula CH4. We have a central carbon attached to 4 hydrogens. Wow, I almost forgot the names of these atoms. So again, I was always curious, why is this called methane? It's kind of funny to me, at least when I was first learning the names. So we see that we have 1 carbon in this whole entire molecule. If we have 1 carbon, the prefix for that is going to be METH, which is meth. Because we have an alkane, the suffix then will be ane. And that's how we come up with the name for this molecule, methane. I don't know, I just thought it was very interesting. So this is a quick example. And then let's say we have a cycloalkane or a cyclic alkane. Let's do a quick example of this as well. So we have a triangle. I know we don't see too much, or so far we haven't seen too much of a triangular molecule. Seems kind of interesting, but this is the simplest cycloalkane. this triangle here, let's see, we have 1, 2, 3 carbons. If we have 3 carbons, the prefix that we use for that is going to be prop. So P-R-O-P, because we are dealing with an alkane, we have the suffix of A-N-E. Then because we have the alkane joined like in a ring, we add a prefix cyclo, and it's all one word. Again, cyclo because it is in the form of a ring, and propane because we have 3 carbons, and then of course the A-N-E because we are dealing with an alkane. So together then this molecule, this triangle, is called cyclopropane. All right. So we also have some common substituents naming, or names of common substituents. So I'll just write substituents as sub. We have one with 3 carbons, and then the other 3 will have 4 carbons. Starting off with the one with 3, I kind of see it as like a tilted Y. This is called isopropyl. And then we have, and of course our R just means the rest of the molecule. It could be a hydrogen, it could be another long chain, it could be a ring, it could be anything. This one here, that's going to be called sec-butyl. This is isobutyl. And the naming of these substituents is not following the rules or the prefixes that I have here. These are just common names, and you just kind of have to memorize these. And then another one, or the last one, I believe. Yes, this should be the last one. This one is my favorite, actually. I like this one because it looks like a chicken's foot. And this one here is called tert-butyl. All right, so we have these 4 common substituent names. Okay, let's go ahead and move forward to the steps to take when doing nomenclature. Some of these steps will not make too much sense until we start applying it to actual practice problems, but I'll try my best. If not, you can just go ahead and copy these down or memorize these, and then try to apply them to our example problems, okay? So first step is to identify the parent chain. So we want our parent chain to be the longest continuous chain in the molecule. If we have, let's say, 2 different ways to number, or not number, but we have 2 possible parent chains, then we can go ahead and look for the chain with the most substituents. So we want a long continuous chain with the most substituents. And once we find that out, we can go ahead and kind of name that chain like how we named this methane group. And this will go at the end of the name of the molecule. So let's kind of do an example to identify your parent chain. I'll go ahead and draw 2 of the exact same molecules. So just quick eyeball, I think this linear chain looks long to me, and this curved one here looks long to me. So let's go ahead and number these, or not number, but we can go ahead and count our carbons and see which one has the longest chain, longest meaning the most carbons, right? So on this one here, again, I'm going to count this linear branch. We have this 1, 2, 3, 4, 5, 6, 7, and 8. So on this counting pattern, we have 8 carbons. Let's do the one that kind of bends down. So we have 1, 2, 3, 4, 5, 6, 7. So this we have 7 carbons. Again, we want a long chain, or the longest chain, and the longest chain will have more carbons. We're comparing 8 and 7. Of course, 8 is longer or more, so we will use this linear one to be our parent chain. When we were doing examples in discussion, I noticed that a lot of students tend to try to just look for any linear or just going straight across the molecule. That will not necessarily be your parent chain. You just have to kind of do trial and error and find your longest chain. So your possible parent chain could have been maybe this. It could have been maybe curving the other direction of some sort, maybe going like opposites like this. You kind of can't just assume that this linear one will be your parent chain. So that's just kind of something to be mindful of when you're doing nomenclature. Second thing to do when doing nomenclature is to identify your substituents. Again, I'll just kind of simplify substituents into sub. So we can kind of bring up the same exact molecule as we did in step 1, just to kind of get comfortable with this idea of nomenclature. So again, we already said that this linear branch here is going to be our parent chain. So a substituent, wow, the word is hard to say, but it's just the branches off of the parent chain. So if we already said that this one is going to be our parent chain, then this group here, and this group here is going to be our substituents. So we located our substituents. We can go ahead and kind of name them now. Again, we have certain prefixes and suffixes for these. So let's start off with this, which is of course identical to this one right here. So we don't count the carbon that's on our parent chain. That's specifically just exclusive to the parent chain. But for this end, then we have 1 carbon. So if we have 1 carbon, the prefix for that is going to be meth, right? So we have METH, and because we are dealing with a substituent and not the alkane chain or the main parent chain, we use the suffix of then YL. And of course, the branch sticking up on the right will also be a methyl group because there's only 1 carbon. Now, what about the one pointing downwards? What is that one? Well, let's see here. Again, we don't count this carbon because it's part of the parent chain. We have 1, 2. We have 2 carbons then. Because we have 2 carbons, we have the prefix of ETH, and because we're dealing with a substituent, we have the suffix of YL. So we have successfully identified the substituent. We have 2 methyl groups and we have 1 ethyl group. So once you start to get a hang of this, you don't need to we don't need to circle the substituents. We don't need to go ahead and kind of write it out like this. But again, we're new to this, so we'll do it slower. Third step when doing nomenclature is to appropriately and systematically number the parent chain. And these rules are these steps exactly, except for number 1. It's not really like you have to follow these exact steps in this order. It's just kind of something that I made up right before lecture, but it's still a good way. As long as you do everything else, besides number 1 being, of course, you have to find the parent chain first. The other steps are you can kind of like mix and match. So numbering your parent chain. How do we number our parent chain? We number the chain to give the substituents the smallest order of the locant. So what a locant is just which carbon number you're at. And then if we have a tie on that, then we can go ahead and use the alphabet rule as a tiebreaker. So let's say we have methyl, and then we have a ethyl group. Again, number 3 might not make too much sense right now, but we will definitely apply this rule when we get to our examples. So again, we are dealing with numbering of our parent chain. First step is, or the first rule we go by is the locant rule. And if there's a tie, we use the tiebreaker, which is the alphabetical rule or the alphabet rule. Again, right now we're kind of focusing on this alphabet rule. So if we have methyl and ethyl, of course, we look at the M and the E. E comes first in the alphabet. So we'll go with whatever route will give this ethyl group the lowest locant number. So it's kind of like it's like a sub-unit of this rule then. Then number 4 is to kind of, I don't know what this formal name of the step is, but I would just say to count your substituents. Maybe this step should have been with number 2 here, but let's go back to step 2 then. So to count your substituents, so we see that we only have 3 substituents now. We have 2 of the same, we have 2 methyl groups, going back to this key here. So if we have 2 of the same substituents on the same molecule or the same parent chain, this is what I mean by the number of substituents. So we have 2 methyl groups, then we'll use the prefix of di for the naming. So we have 1 ethyl group and then we have 1 dimethyl group. So I kind of like listed it out here. We have dimethyl and then we have ethyl. So I'll just say maybe refer to step 2. Again, these aren't formal steps. It's just something that I kind of made up on the spot. Okay, so step 5 is to just put everything in order. So wait. Okay, I believe a textbook has some sort of formula to go by, but I never really learned that, so I don't really think you need it. But if you think it helps you can go ahead and use that. But I don't know it by heart, so I will not be providing that in this video. But yeah, go ahead and check out your textbook if you want the exact formula. So in nomenclature, we don't have any spaces like we do in just regular English. We separate numbers from words with hyphens. Numbers and words using hyphens. So I'll just put in parentheses. And then we use commas to separate numbers from other numbers. And again, we use commas for those. And then we arrange our substituents in alphabetical order, and then we just slap on the name of our parent chain. So let's do an example using the same molecule that we've been doing. So I kind of just copy this over. Paste this here. Okay. So again, not only have we already identified a name, all of our substituents and identified our parent chain and numbered that as well. Again, we numbered it 1, 2, 3, 4, 5, 6, 7, 8. So we know we have 8 carbons on our parent chain. If we're dealing with 8 carbons, we have the prefix of oct, so OCT. We're dealing with alkane, and we're dealing with the parent chain, so we use the suffix of ane. It's not in a ring, so we don't need to go ahead and add the prefix of cyclo. Again, we kind of arrange our substituents in alphabetical order. So we see how we have dimethyl and we have ethyl. But if we're going to use the prefixes for the substituents, we don't need to keep or take into consideration any of these prefixes in the alphabetical order arrangement. We just need to focus on this M here. So this M and then this E, of course. And for the common names of the substituents, the only, I guess, prefix that we need to take into consideration when we're doing this the alphabetical order is the sec and the tert. But the iso, or the iso for this one and this one, we take into account the I. So I guess to clarify, so isopropyl we take into consideration I. For sec-butyl, we take into consideration B. Isobutyl, again, I, and then tert-butyl would be the B in butyl, okay? So going back to the alphabetical order of the substituents. So we only have 2 groups here. We have dimethyl and ethyl. We don't take the di part into consideration. So we have M versus E. E comes first. So we have ethyl group, but it could be anywhere in the molecule if we simply just put ethyl. We need to kind of have an identifier. So we just put a number in front of the substituent name to signify where on the parent chain it is. So we know that we have ethyl group on carbon 5 because this is how we numbered it this way. So we can just put 5-ethyl. And again, we are separating numbers and words with hyphens. So that's what I did here. Then we have our dimethyl. We have methyl groups on carbons 2 and 6. So 2, 6, because we're separating numbers with other numbers. 2,6-dimethyl. Let's give us more space here. And just slapping on our parent chain. We don't need hyphens, we don't need commas for just combining our substituents and our parent chain. So there we go. We have the proper name for our molecule for this right here. We have a 5-ethyl 2,6-dimethyl octane. All right, we can go ahead and now go over the examples that we did in class this week. I know that I kind of switched it up in Thursday discussion and I went ahead to put names, and then I did how you guys draw out the molecule. But for this recording today, I'm just gonna do drawing of the molecule and then naming them. I want to go ahead and do it forward before we're able to kind of do it backwards. And I'm sure that there's plenty of practice problems that Professor Dong or your textbook provides already. So I believe that this video can just help you kind of build the fundamentals to go ahead and do more nomenclature and harder problems in the future. So again, starting off with a practice problem, we can go ahead and do the first example that I believe I brought up in the discussion. So again, the first thing we do is you go ahead and identify the parent chain. Our parent chain is right over here. Again, I saw a lot of students that they decided to just pick this straight linear branch. I always said that the chain just needs to be continuous. It doesn't need to be straight. And then numbering our parent chain. We're just going to start out at the bottom left, giving it 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 carbons. And some students were wondering why we didn't count it this way instead. So let's do it both ways. So we have the white route giving us 8 carbons. And we also have substituents on carbons. Let's see. So if we do it this way, we have substituents here, here, and here. So we have substituents on carbons 3, 4, and 6. Let's see if we do it in the blue route, or let's do this bright green. If we count it this way, then we'll have 1, 2, 3, 4, 5, 6, 7, and 8. Again, same number of carbons because it's the exact same route, so I wouldn't think otherwise. But now we have substituents. Let's see, it's here, here, and here, right? So we have substituents on 3, 5, and 6. So we see that the chain is going to be, of course, the same length, but for our substituent locants, we have 3 and 3, so those are equal. We move on to the next one. We have 4 and 5. 4 is lower than 5, so we want to go with this one right here because we want the lowest locant number for the substituents. So that's why we're going to go ahead and continue with the white route. Okay, so of course, we already kind of located where our substituents are. We have 1 carbon for all 3. So we have the prefix of meth. Because we're dealing with substituents, we add the suffix of YL. And because we have 3 of the exact same substituents on the parent chain, and we have, again, 3 of those, we use the prefix of tri. So we have trimethyl. And our parent chain, we said, has 8 carbons. So we have the prefix of OCT. Because we're dealing with alkane, we have the suffix of ANE. So now we can put everything in order. We put our substituents first. We don't need to worry about putting this in alphabetical order for our substituents because there's only one kind of substituent, that is just 3 methyl groups. So of course we need to go ahead and label where our methyl groups are. Again, we had said earlier when doing this thing that we have methyls on 3, 4, and 6. Those are where our methyl groups are. And just slapping on the parent chain then would be octane. So the name of this molecule is 3,4,6-trimethyl-octane. So this was example A. Okay, let's move to B. All right. So this time we have included a cyclic alkane or cycloalkane. So we have this little fella here. So because obviously we know this is hexagon, so it has 6 carbons, it's a 6-membered ring. And then this only has 1, 2, 3 carbons longest. This one will be the parent chain. I believe in your textbook it says that, let's say we have this chain having 6 carbons as well, then we choose the cyclic alkane to be our parent chain and the linear alkane to be just your substituent. But here in this example, we have kind of a clear indicator that this ring will be our parent chain because it has more carbons than this one does. So again, we have 6 carbons. So that's going to have the prefix of hex, H-E-X. We're dealing with an alkene, so we have a suffix of A-N-E. We have the alkene being in a ring, so we have to add the cyclo part. So we have a cyclohexane as our parent chain. We have located our parent or our substituent being right here, this one right there. And that looks to me like one of the common substituents. Let's take a look here. And yes, this indeed is one of our common substituents. That's going to be our sec-butyl. Okay, so we have a sec-butyl. And for the numbering of the parent chain, because there's only one substituent, by default, this is carbon 1. And we don't need to continue numbering our parent chain because we don't have any other substituents. The important one is that it's on 1. So now putting this all together, we only have one substituent to consider, so we don't need to really worry about our alphabetical rule. So we just put 1 to identify where our substituent is on our parent chain. So 1 sec-butyl cyclohexane. So that one's rather simple. Next one we have all right, we have something that almost looks like a ring, but is not. Our parent chain is going to be this route over here. And our counting is going to be 1, 2, 3, 4, 5, 6, and 7. So we have 7 carbons. Let's say we went a different route. Let's say maybe we had this. Then there would be only 1, 2, 3, and 4. So there would only be 4 carbons. So we'll stick with the yellow route. All right, so we have 7 carbons. I'll go ahead and erase these because we need to number them later. Okay, so we identified the parent chain. We have located then our substituents here and here. Let's go ahead and name those substituents. On the left side here, we have a methyl. Again, we have 1 carbon, so we have the prefix of meth. We're dealing with a substituent, so we add on the suffix of YL. Then on the right, we have an ethyl because we have 2 carbons and it's a substituent. All right, so let's go ahead and now formally number our parent chain. So we can kind of clearly see for this one, if you go from the top to the bottom, our locants would be all the way down here and then here for our substituents. But if you start it from the bottom to the top, you can see that we have them right here. So that was a little bit more obvious. So we can start labeling from the bottom then. So we have 1, 2, 3, 4, 5, 6, 7. So we don't need to follow the alphabet rule. So we first give priority to the locant rule, and then if there's a tie for that, then we can go ahead and move on to the alphabet rule. So here I only use the locant rule. All right, so we numbered our chain, we identified our substituents, we named these substituents. Let's go ahead and name the parent chain. So again, we have 7 carbons in our parent chain that has the prefix of H-E-P-T, so hept, and because we're dealing with an alkane, we add the suffix of A-N-E. All right, so we can now go ahead and construct the name. So now, of course, we need to put everything in alphabetical order for our substituents. Here we're dealing with 2 different ones. So E comes first before M in the alphabet. So we'll put ethyl first in the name. And of course, the ethyl group's in carbons 3. So we have 3-ethyl. And then our methyl's on carbon 2. So 2-methyl. And then we just slap on our parent chain. Heptane. So this molecule is named 3-ethyl 2-methyl heptane. Okay, example D. I believe most discussion classes got this one wrong. I'll try to explain maybe some of the mistakes that were made. So again, a lot of students thought this branch here, or this portion of the molecule here, was our parent chain, because the way I explained identifying the parent chain, this happened to be linear as well. But of course, through the examples, you were able to see that they were not always just straight, right? This one was kind of bent, so was this, and this one was just the ring and not even considering this at all. So if we do this one, then we only have 1, 2, 3, 4, 5 carbons, but let's try a different way. Let's do this. Or maybe even this, because it's the exact same kind of curve, right? Except instead of curving to the left, we're just curving to right. So it doesn't really matter. So let's do it curving to the right. We can get 1, 2, 3, 4, 5 carbons. So we can see that both routes either going straight or kind of curved here like this. That would give us the exact same number of parent chains, so the length of parent chain. But if we did this route, we would have, let's see, 1, 2, and 3. If we did it this way, let's see, we get 1, 2, 3. So maybe they're actually identical then. Either way, I'm just going to stick with this route here. So now not counting, but numbering our parent chain, we have, starting from the top, we have 1, 2, 3, 4, 5. I believe the mistakes weren't identifying the parent chain. I believe the mistake was when people were naming this molecule. Okay. Obviously, we already identified or located our substituents. We said it was going to be this, this, and this here. This, again, to me, looks like a common name. Let's go ahead and look at our key. And of course, we have our isopropyl. Again, to me, this looks like some variation of a Y. So going back to the example, we see that this is some sort of Y, or is exactly in Y in our case. So we have our isopropyl here to the left. Then, of course, our very familiar methyl groups. So we have 2 methyl groups on the exact same parent chain. So we have dimethyl, and then we have our isopropyl. Again, we don't take into consideration the prefix for our substituents. When we're thinking about ordering this alphabetically, we're dealing with the M and versus the I. And for our parent chain, we have 5 carbons, so we have the prefix of pent. We're dealing with alkane, so we have suffix of A-N-E. We don't have a cyclic alkane, so we'll just leave it as that. Okay, let's go ahead and construct our name for this molecule. So of course, we're comparing I and M, or yeah, I and M. So then our isopropyl group will come first in our molecular naming. Isopropyl is in carbon 3, so 3 isopropyl. Then we have our methyl groups on 2 and 4. we have a dimethyl group. So 2,4-dimethyl, and then slapping on the parent chain, pentane. So the name of example D is 3-isopropyl 2,4-dimethyl pentane. All right, moving on to example E. So for this example, then, a lot of students made mistakes and they got excited when they first saw this molecule. They recognized this common substituent group. They're like, oh my gosh, it's the chicken foot. However, just because we know that this is part of our common substituents does not mean that it cannot be part of our parent chain. So that's where a lot of people just assume that this was going to be our parent chain and this would be our substituent, but that's not the case. Our parent chain is actually going to include what we thought was going to be one of the, chicken, I guess, fingers. But yes, this right here is going to be our parent chain. Let's see how many carbons we're able to get. So we have 1, 2, 3, 4, 5, 6. So we have 6 carbons. If we did it to include, let's do a different color. Let's just write it in maybe green. So we did the linear chain, then we would have, let's see, again, 2, 1, 2, 3, 4, 5, 6. So we see, of course, we have the same exact length for our parent chain possibilities, but because if we follow the white route, so the one that's actually highlighted, we get 1, 2, 3 substituents. And then if we follow the green route, we would only get this chicken foot as our substituent, and that counts as just 1. So 3 versus 1. And when we're identifying the parent chain, not only do we want the longest parent chain, but in our case, of course, we both have 6 carbons, then we can move on to looking for the parent chain with the most substituents. Obviously, 3 is a larger number than 1, so we can go with the one that has more. So it has 3 substituents. In our case, that's the one that's highlighted, so the one in white. So that's why we didn't include our tert butyl into the naming. So I'll go ahead and erase what we have in green and this as well. Okay, so we located our substituents by doing this example. We can see that we have 2 methyl groups here on top. So we have dimethyl. And then about the bottom, we have, of course, those 2 carbons. So we have an ethyl group. Then our parent chain, we have 6 carbons, and that's an alkane, so we have an hexane. So just now identifying or properly naming our molecule. So again, we are comparing the letter M versus our letter E. E comes first. Ethyl is on our carbon 4. And then we have our methyl group on carbons 5. But we have both our methyl groups on carbon 5, so we can just say 5,5-dimethyl. And just slapping our parent chain, hexane. So the name of this molecule is going to be 4-ethyl 5,5-dimethyl hexane. Actually, taking a look at my answer key now, I numbered our parent chain incorrectly. So instead of numbering it as I did earlier this way, it should have been this way. So if you caught that mistake, good job. Again, our parent chain is still the same. It's going to be this one right here. but instead of numbering it from the bottom to the top, sort of, we're going from the top to the bottom. So we have 1, 2, 3, 4, 5, 6. So that's the correct numbering now. So again, kind of just redoing the process we did earlier. We knew that the ethyl group comes first, so that's 3. So 3 ethyl. We have methyl groups then on carbons 2, so 2, 2 dimethyl hexane. So again, we made that mistake, but we caught it. That's okay. So example E, the name of this molecule is 3-ethyl 2,2-dimethyl hexane. All right. Now moving on to some cyclic or cycloalkanes. Let's start off with A again. We only have 2 examples because it's the exact same way as we do with the ones that are acyclic, but we just add on that cyclo portion of it, right? So here we have, let's see, this molecule. All right. So again, we're identifying our parent chain. We can see it's either going to be one of our branches or the linear or acyclic alkanes or the cyclic alkanes. So these would be the acyclic, and then this 6-membered ring would be our cyclic. Of course, this is a 6-membered ring. We automatically tell that that has more carbons, so it has more length. So that's going to be our parent chain. Now, if we're going to number our parent chain, so let's first highlight that. So numbering, of course, we're going to start at one of our substituents, but we don't know which one could have started off with. So again, we can go ahead and name these first. We are very familiar now, probably, with our methyls. And this is some variation of Y, right? It's kind of just tilted over. We have a isopropyl. Again, that's one of our common substituents that we have to just memorize. So let me go ahead and count at one of our methyl groups. Let's start off with this one here. So we have 1, 2, 3, and 4. So although I comes first in the alphabet before M, if we start the counting here, then we would have substituents on not only one, let's see. So we have 1, 2, 3, 4, or maybe 1, 2, 3, 4. So either way, the second location of our substituent would be kind of far, but if we did it this way, we would have 1 and 2 and 4. This is why I did it this way. And of course, the locant rule is first in priority, and then we move on to the alphabet rule. So this is why I started off here. So we have located and identified our substituents. We have numbered our parent chain. Let's go ahead and name our parent chain. So again, we have a 6-membered ring. We have 6 carbons. Because we have 6 carbons, we use the prefix of hex. We're dealing with alkane, so we add the suffix of ane. We have a ring, so we're going to add this cycle prefix. All right, so let's go ahead and construct the name for this molecule. Again, I comes first in alphabet, so we can go ahead and put that first. And one more thing, we have dimethyl because we have 2 methyl groups on the exact same parent chain, right? Okay, so again, isopropyl comes first in the naming. It's a carbon 4, so 4-isopropyl. Then we have 2 methyls, so we have it on carbon 1 and 2, so 1,2-dimethyl. That's all of our substituents, so we can go ahead and just slap on our parent chain. So we have 4-isopropyl 1,2-dimethyl cyclohexane. Next one. All right. Again, we have a cyclic, and then we have two acyclic alkanes. So if we count this one, we would have 1, 2, 3. If we were to make this our parent chain, this one would not even be in question. That's just 1, 2. And then, of course, there's a 5-member ring. 5 is the longest, the longest alkane that we have in this entire molecule. That's going to automatically be our parent chain. So let's kind of highlight that to identify that's our parent chain. So because we have two substituents, if we started the counting here and then going down, we would have 1, 2. If we went from the bottom to the top, we would have 1, 2. So either way, all the substituents would have the same distance and have 1 and 2 being the locate number. So we can go ahead and move on to then the alphabet rule. So we want, let's see. So we have the top and bottom being one of our common substituents. Let's go ahead and look at our key. So we have then our sec-butyl as well as our isopropyl. Again, we have our sec-butyl and isopropyl. We're dealing here with our B versus our I. Of course, B comes first in the alphabet, so we'll go ahead and put this as 1 and then 2 for the numbering of our parent chain. So now that we have located our substituent, name our substituent, let's go ahead and name our parent chain. Again, we have 5 carbons that has the prefix of pent. We're dealing with alkane, so we add ANE. And of course, by now, we probably are really familiar that if we have a cyclic alkane, we add the cyclo prefix. So we have a cyclopentane being our parent chain. So now we can go ahead and construct our naming of this molecule. Again, we already said sec-butyl versus isopropyl. Sec-butyl will come first. So then we will have 1 sec-butyl, 2 isopropyl, and then just slapping in our parent chain because we're done naming and putting in alphabet order our substituents. So we can go ahead and just include our parent chain. So for example, B then, for our cyclic alkane, we have a 1 sec-butyl, 2 isopropyl cyclopentane. And don't worry, we only have 2 more examples left. These are going to be acyclic alkanes. All right, so I already know that this right here is going to be my parent chain. It obviously, to me at least, looks the longest here. You can go ahead and try different rounds and see if you find a better one. If you do, let me know. I'm kind of doing these examples at the same time right now, just as you. So we're learning together, right? Okay, now numbering our parent chain. This one is, again, a little bit maybe more straightforward. So we start counting this one. We have locants on 2. If we count this way, then our first locant would be, let's see, 1, 2, 3. It would be on the 3rd carbon. 2 comes first, so this way would be a lot more better. Let's see, so we have, let's see, 1, 2, 3, 4, 5, 6, 7. And then our substituents, let's see here, we have a methyl, another methyl here, 2 more methyls down here. And then we have a isobutyl. Just double checking. Actually, this is isopropyl. Sometimes I even still get confused. Just double checking. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So, all right. So we identified and located our substituents. We have said that this is going to be our parent chain that has 7 carbons. So if you have 7 carbons, then let's see. We will have the prefix of hept. We're dealing with alkane, so we have ane as our suffix. We don't have a cyclic alkane. We don't need to add the prefix of cyclo. Here in this molecule, we have 1, 2, 3, 4. We have 4 methyl groups. So then we have a tetra methyl. Okay. So now constructing our name, we're comparing our I and our, let's see, our M. So then we have a 4. Let's do this in white. So we have a 4 isopropyl. And then we have methyl groups on carbons 2, 2, 3, and 5. And let's see, we have a tetramethyl. And that's all of our substituents. So we can go ahead and just slap on our parent chain. So we have a 4 isopropyl 2235 tetramethyl heptane. And last example that I have for you guys today. Let's see, so we have this here, and then looks like almost 2 chicken foots on each end of this line. Maybe this line could be a little bit shorter, actually. All right, so I'm just going to say maybe this is our linear or our parent chain. 1, 2, 3, 4. So either way, it would just be the same. So I just chose this for fun. You could have chosen this way, or maybe bending the other direction. Doesn't really matter. And then the counting would be the same on both sides, and we always will just have 2 methyl groups, so it wouldn't matter. I'll just count it this way, 1, 2, 3, and 4. So our parent chain will have 4 carbons. That's going to have the prefix of bute, or yeah, bute. We're dealing with an alkane. We have a suffix of ane. That's our parent chain. Then we have, let's see, 1, 2, 3, 4 methyl groups. Right, let's just kind of label this for formality. Okay, so we have 4 methyl groups. That's going to be tetramethyl. Okay, let's go ahead and build that name for this molecule. So we don't need to worry about, again, the alphabet order for the ordering of the substituents because we only have one kind. We have our methyls, and we have already said that since we have 4, it's going to be tetramethyl group. So we just need to locate the methyl groups. So we have methyls on carbons 2, 2, 3, 3. And then, of course, we have tetramethyl. And our parent chain is butane. So this last example here, this is a 2233 tetramethyl butane. So that was definitely longer than what our discussion was, but I want to kind of break everything up and go into more detail and explain all the examples that we weren't able to go over in class. So hopefully this helped you. And again, if you have any question, this is my email right here.